So let me set up for the demo here. Just like with the electrostatics timed assessment demos, I'm gonna do a timed assessment demo of magnetostatics, and I'm putting quotes around the demo because, as I've done with electrostatics, what I'm gonna do with the multiple choice portion of magnetostatics demo is I'm going to cheat. So it's not really a demo in the sense of something that someone else in the class should be doing. I'm gonna be using ChatGPT to basically cheat through this multiple choice, and I guess what it is a demo of? It's a demo of I guess just me as your instructor keeping up with what's technologically possible, and a lot of the policies that are here that are frankly outdated, like a 10-minute time limit, which is a really short time limit, and it's meant as a really short time limit when I was concerned about students cheating with a check, not ChatGPT. With the ChatGPT, I know you can cheat in less than 10 minutes. I don't know if there's any technological measures I can put here that will absolutely prevent that. So what I'm doing instead is, me going through this assessment with the ChatGPT, see how well I do, in terms of both the accuracy, 100, percentage of correct answers, and the speed, the time, and I'm gonna do it a second time. This time just on my own, not cheating, and that will be my friendly competition with the ChatGPT. And there have been fairly close times when I was. Like ChatGPT has gotten better over the last 2 years or so. It has always struggled somewhat with the magnetism, so I don't know how well it'll do. Now with the electrostatics, I think I did auto, and it didn't do so well. And some of the issues was it gave me a answer first, and then later in the response it would change. So let me try this. I'm gonna make it. Let's see, if I do thinking mini, can I still paste in? Okay, I think I can still paste in photos. Or if I do thinking, I could do the standard thinking. Let me try it that way. I think standard mode, thinking mode, is the most comparable to the ChatGPT 03 that I used to use in the previous semester. So in this mode, again, let me cheat through this multiple choice. I'm using the word cheat to make it unambiguous because the rule says no outside help. If you as a student are doing what I'm gonna be doing for the next 5, 6, 7 minutes, that's cheating. No if, no like but or whatever. Please don't do it. If you've done it, don't admit to it. And frankly, timed assessments at this point, it's really practice for you to get a sense of how well you understand the material and how well you perform under time constraint. So, there's no reason to cheat. So, I'm just continuing to test ChatGPT, how well it answers these multiple choice questions and how quickly it answers. So with that intro, let me just put in a prompt that will help me cheat efficiently. Hi, I'm practicing through my magnetism class multiple choice questions. I'm going to paste in screenshots of questions. Would you please give me the answer as quickly and accurately as possible, maybe followed by a brief explanation. For the answer, please number it A, B, C, or D in order. Some questions may have 5 choices. Also, okay, I'll enter, it'll acknowledge, and I'm gonna start, and I'm basically gonna try to do as quickly as possible, copy and paste here. So, all right. Yeah. I'm pretty sure it knows I'm cheating, not practicing, and it's just gonna help me anyway. It's an amoral tool, which I don't mean it as an insult. I mean it as a correct statement of fact that despite the AI safeguards and whatnot, it doesn't have moral judgment. It doesn't have the kind of hesitations that a human tutor would. Human tutor who wants to help you learn instead of just giving you answers. So that was a C. Probably, I don't know. Wow, yeah, and it's quick. I remember, yeah, so I'm basically gonna be limited by how quickly I can copy and paste. But so we'll look at the accuracy here. If accuracy here is low, like the last time I did it for electrostatics, I may have it to extend the thinking instead of quick thinking. Am I? All right, maybe. Oops. Yeah. Okay. And just stacking additional. So let me put in the question and then the field lines. Yeah, probably. So I have 6 already here, and then yeah, I think if I drew. Didn't see that. So put this in, and then it answered the 5 as A. Alright. Did it already answered? Yeah. So, alright. 6 as D. This I think I have to do it as 2 images. So I'll put one here. Put this in. So question 7 B. It's gonna be answering 8 while it's doing that. Let me put in the 2 screenshots for these. So 8B. By the way, at the speed that I'm going with the copy and paste, I'm not evaluating any of these statements for correctness. I'm just, make it as hard for me as possible to beat ChatGPT on time. I think I'm gonna be done in like 3-4 minutes. I mean, ChatGPT will be done in 3-4 minutes, which means I don't think it's gonna be easy for me to beat. We'll see. It's a friendly competition, so I want to make sure I will give ChatGPT as big of a chance as possible to beat me. Both on, probably, hopefully, not on accuracy, but on time, definitely. This is taking a lot longer than normal. That's interesting. Alright. Answer the D. And as soon as that finish, let me just in this time, make sure. Oh, wait. See, alright. So, let me do save progress and then submit it in. If there was any operator error, we'll see. 80%, that's decent. Let's see. 3.7 minutes. So my goal always is to beat it on accuracy, which I might still do, and time. This is a really short amount of time. I don't know if I can beat it, but we'll see. Let's first find the 2 questions that I missed. And see why it missed. So, question 1, contrast, electricity, magnetism, and O'Conley dipoles. Yeah, that's basically correct. The rest I assume are incorrect. So, question 2, consider a charged particle, and let's see. Yeah, E over B is the right formula. E over B. Yeah, I think that's right. Yeah. Alright, question 3. Incorrectly compares. They prove the forces which, yeah, that's incorrect. So which means it's the correct answer. Question 4. Which correctly describes an expected feature of correctly drawn. Begin on North Poles and end on South Poles. Maybe. there might be other choices that are better answer. That's certainly not right. No charges. Field lines, nope. The velocity has nothing to do with it. You know what? The first choice is right. Yeah. So if you have poles drawn, then yeah, begin on North Pole and on South Pole. Yeah. Yeah. So question 5. Describe net torque on a current carrying net force. So I should read. Net torque on uniform. Okay. Net force is 0. Yeah, that's right. Net torque depends on orientation. Yeah, I think that's correct. Yeah, let's keep going. Question 6. It's gotten 5 out of 5 so far. Magnetostatics, loop dipole, analogy, yeah, statement why a loop of current can be thought as magnet. Okay, let's read it. Magnetic field generated by loop of current. The field points perpendicular to the circle, and then the distance. It looks similar to yeah, I think that's what I programmed in as correct answer. Let me read the rest just in case. Circulate loop, yeah, no charge accumulation. Battery is not an electric type. I mean, not as a primary thing. Create a conducting loop of current. Yeah, that's not it. Yeah, so that's the correct answer. Kind of wordy, but yeah. Okay, question 7, solenoid. Let's see, which of the following does the magnet? Yeah, density is right. It's mu naught IN. That's the formula for solenoid field that I have memorized. So it definitely does depend on loop density. Yeah, okay. So it must have missed one of the, well, 2 of the last 3 questions. It's 7 for 7 so far. Correctly compares or contrasts the Biot-Savart's law with the Coulomb's law. Okay, no, this is wrong. So Biot-Savart's law shows the inverse square, 1 over r squared. Yeah, this is wrong. For a long straight current, now long straight charge also has a falling off by 1 over r. So the correct answer here should be, yeah, both of them describe an inverse square law. So yeah, it got that wrong. You know, write down Biot-Savart's law. There's 1 over r squared. This comes from the long derivation, which you gotta, you know, compare point source to point source, and a long line of source to a long line of source. So ChatGPT was just wrong. I think if you question him further, maybe they'll get it correct, but under the time constraint, he got it wrong. So missed that. Question 9. Let's see. Let's see, for a single loop, the top of the loop current point into the page, so the magnetic field should be pointing to the left. Yeah, that's the right hand rule. It's pointing to the left within the center. I has what magnetic direction, so it should be minus x direction. So it's choice between. Oh yeah, so it got it wrong. It's on top into the page, bottom out. Yeah, yeah. So ChatGPT struggles with the application of the right hand rule. So it doesn't surprise me that it missed the direction. And is this then? So is this the correct one? Maybe. I'm not sure. Without doing the derivation. So let's see. Yeah. So I think so Biot-Savart's law has a factor of 1 over 4 pi in it, and I think when you do integral around the loop, then you get this as the correct answer. So I think it got the magnitude correct. It just missed the direction as one would expect. As I've come to expect large language models to do. It really struggles with the application of right hand rule. It doesn't. It does a statement of the right hand rule fine, just doesn't know how to apply it well. And let's just double check to make sure that this is the correct answer, because you know I might be misremembering. So I'm gonna log in as an instructor and go to test students attempt and show you that particular question that that ChatGPT missed it, and that this option, the third option, is the correct answer. So here the question, I think it was 9. Yeah, question 9. The correct answer is, yeah, that one. Yeah, good. Okay. So those are the two, I think. So you must have gotten question 10 right. Question 10, fundamental source of a magnetic field. Yeah, an electric current or a moving charge. Yeah. Yeah. Good. Yeah, so it pretty decent, 80%. That's what I expect from a strong A student. 3.7. Now, if I saw that, then I might be suspect. Oh, you cheated using ChatGPT. I don't know. But okay, so that's what we have. ChatGPT spent 3.7 minutes to get 80%. Again, decent performance. Now I'm gonna use my second attempt as test student to try to beat that. By which I mean I'm gonna try to get better than 80%, faster than 3.7 minutes. As I might have mentioned, it's hard even for me to do that fast and accurately still. So takes a lot of concentration. So for the next, hopefully, less than 4 minutes or so, I'm not gonna say a lot or anything other than excited utterances. Just gonna be silent, working through the questions as quickly as possible. I do have a bit of an unfair advantage in that I've written these questions, I've looked at them so many times that a lot of times I simply recognize the correct answers from memory, that rather than working things out right now. But with all those unfair advantages in mind, I'm still trying to beat ChatGPT on time and accuracy. So I think I'm all set. I'm gonna try to avoid writing things on screen as much as possible, just because writing things means slowing down. But I will have annotation available just in case I need to. So, alright. Let me start, and then I'm gonna try to be really fast. Okay. Release from rest. No force. Compass, north, south, orange that way. Not Polaris. Okay. Attraction and repulsion. No. Like repel, yeah. Correctly compares. But no. No. No, probably this one. Yeah. Particle accelerator, basically speed of light, 2.7. Role of magnetic field, it bends the. Yeah. Motion, no. No. Bend, yeah. Okay, consider. Okay, that's the low. Okay, it could be generated by solenoid. Shaded square area. There's net current going. So Ampere's law, be that. Be that. So into the screen. From my perspective, into the screen. So there's net current going into the page. Straight line of current coming towards you, magnetic field counterclockwise. Circles going counterclockwise. Does not, it has to be carrying a current. I think we had that, and that they are both inverse of square law. Ferromagnet, magnetic domains. Alright. Am I? Okay, I think I'm gonna beat it on time and 100%, yeah. Okay, I'm still keeping up, and so of the 6 minutes, ChatGPT spent 3.7 minutes. I spent only 2.3 minutes. So I don't think that might be my personal record. I don't think I've done this 10 question set in less than 3 minutes before. So that's why I do this competition, because until I try, I don't know what's my limit. So I spent 2.3 minutes beat ChatGPT both on accuracy and time. So let me just slowly scroll through, and I think right now there was an element of luck as well. There weren't any questions that required a serious calculation or derivation of formula on my second attempt. So I feel lucky on that. So anyways, what I'm gonna do is, so all the answers are right because I got 100%. I'm just gonna slowly scroll through it. In case you wanted an explanation, my recommendation to you: take a screenshot, ask ChatGPT. It'll probably give you a correct answer. Now, if it gives you an answer that doesn't make sense, then ask me. Then I'll try to explain as well as I can. Maybe sometimes ChatGPT gives you a wrong answer, so it might not be explaining right because it's confused itself. Not that it's confused in the sense we human beings can be. So let me slowly scroll through. This is question 1. This is question 2. Question 3. Question 4. Question 5. Question. Ooh, can I zoom out enough to? Yeah. Question 6. Yeah, just so that someone can take a whole screenshot of the whole thing. Let me zoom back in. Question 7. Question 8. Question 9. Ooh, let me try this. So this is the question that ChatGPT missed, and because I thought it would be a waste of time, I didn't ask it to explain. So let me ask for ChatGPT's explanation. Why is this right? Okay, I tried the assessment again, which means I was lying before about practicing again, and one of the questions you missed earlier, I got it right this time. Just being a bit of a jerk. Right this time. This is the correct answer, right? And let's see if ChatGPT will argue with me. While it's doing that, here's question 10, and that's the last of the 10 questions that I got all right. And as soon as it's done answering, I'll either argue with it more or move on. Correct, yeah. But I don't think your explanation is comparing apples to apples. If you are going to use magnetic field of a long line of current, you should compare that to electric field of a long line of charge. Let me see where it's going and if it's worth arguing or this is like comparing a single charge field with a dipole field. You can't do that. Yeah, you're so yeah. B is still previous question, I think. Coulomb's law, Biot-Savart. Can you give me an actual statement of a Biot-Savart's law rather than as applied to a specific current distribution? Maybe two more back and forth. So once it gives me Biot-Savart's law, I want to point out to ChatGPT that it literally has 1 over r squared dependence built into it. Some of it might cancel out through when you do the integral, but yeah. So can you give me a form without the vec r minus vec r prime on the numerator and instead using the unit vector notation. Gave me a form. So in this form, it literally has 1 over r squared on the denominator. Biot-Savart law is the inverse square law. That's, I think, the last time I'm gonna argue with the ChatGPT. I'm right, it's wrong. I don't really need to convince it that that it's wrong. It's not really convinced anyway. It's all it's wrong. Again, so if something like this happens, then send it to me. I will give you the correct explanation. This goes. There's a more fundamental reason. So, electricity and magnetism, you are gonna see their unification soon, and so with that unification in mind, they are really two sides of one and the same interaction. They are not. So it makes theoretical sense for both to be treated as inverse square law. Rather than one falling off faster than the other. No, none of that. They are both inverse square law. Each source element contributing this, that's exactly like a point charge contributing that. So, yeah. So I think we're done here. Yeah. Good.